Alright, let's do the chapter 6 test review. So, a polygon, first one. A polygon whose sides are all the same length and whose angles have all the same measure is called a regular polygon. If it has all the same lengths, it's equilateral. If it has all the same angles, it's equiangular. In order for it to be a regular polygon, it needs to have both, not just one. All right, so next, name the polygon according to the number of sides, then identify whether it's convex or concave. So we can see the sides 1, 2, 3, 4, 5, 6, 7. That's a heptagon. And then to check if it's concave or convex, we have to see if when we make these line segments into actual lines, all of them, they cannot pass through the interior of the shape. So if at some point I did something like this or like that, that means it is concave. Nothing happened. There was no line that passed through the interior. So this is convex. So we have a heptagon and convex. All right. Let's look at this. Name the polygon. Same thing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's an 11gon. Remember, if it's anything 11 or 13, 14, 15, the one that we stop is this dodecagon, which is 12. Okay, and it is concave because, yeah, this side would be fine. Look, this length would be fine. It doesn't intersect. This line would be fine. This line would be fine. But what happened? Look, this one's not good. This one's not good. This one's not good. This one's not good. So even if just one of them is intersecting the figure, then it is no longer convex. It is concave. Concave. All right, so this is a 5-part question. Is this it? This is very important. Answer the following for the sign. Note, when deciding whether a sign is a polygon, disregard any slightly curved corners. So this is pretty much saying, this is one of those type of questions that's saying, like, assume if this is 5 inches, assume this is also 5 inches. Like they don't want you to be there measuring it, okay? So let's answer the questions. Is the sign a polygon? Yeah, it is a polygon. Why? Because this sign is a polygon because it has 8 sides. That's partially correct. This one's wrong. This one's wrong because that's wrong. But let's read the other one. So this one's right. So let's see if the next one is a better choice or just flat out wrong. The sign is a polygon because it is formed by 8 line segments that each intersect exactly 2 sides at only their endpoints. That's the better answer. So the answer is D. B, name the polygon. It has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. So it's an octagon. Is the polygon equiangular? Yeah. It wants you to assume that everything looks good. The polygon is equiangular because all the interior angles are congruent. D, is the polygon equilateral? Yeah, same thing. They want you to assume that if they look congruent, they are congruent. So this is yes. And then is the polygon regular? Yeah. Why? Because it's both equiangular and equilateral. Let's go to the next one. Classify the polygon as concave or convex. All right. If we do this, nothing passed through interior, so we know it's convex. So we know it's not this, we know it's not this. So now we just narrowed it down to these two. So the figure is convex because there is at least one side that can be extended into the interior. No, that's actually the opposite. This is the definition for concave. So this and this contradict each other. So this answer is not right. So the only one is C. All right. Find the measure of C in the quadrilateral. Okay, so we know it's a quadrilateral. So we know there's 360 degrees inside of every quadrilateral. So we're just going to add up all 4 degrees and then find our C. So 90, plus 90 plus 112 plus measure of angle C equals 360. So this is 180, 180, right? We're getting rid of this to put it up here. 292, 360. Let's subtract 292. Subtract 292. This turns into a 10. 5. 10 minus 2 is 8. This goes to a 15. This goes to a 2. 15, 68. Oops. 15 minus 9 is 68. And 2 minus 2 is 0. So this is our final answer. Okay? Next one. Find the value of each variable. Okay, well, here I have 1, 2, 3, 4 angles, or 4 sides. So I know I have a quadrilateral. So that means they all got to equal to 360, but there's an issue that I have a z and a y. I can't put all these together because I won't be able to solve for anything, right? Because I need just one variable. So I'm going to use the linear pair theorem right here to give me the answer of z, which is 474. So now if this is 74, now I can add up all of these together to give me 360. So y plus 74 plus 94 plus 80 equals 360. And if we do all that math, our y will give us 112. Okay. Find x and then any unknown angles. So once again, same thing, it's a quadrilateral. So all of these angles have to equal to 360. So 4x minus 95 plus x plus 115 plus 90 equals 360. So let's combine like terms. 4x plus x equals 5x. Let's use the calculator. Oh wait, we don't even need to. Negative 95 plus 115 will give us 20. And then what's 20 plus 90? That's 110. Equals 360. 5x equals 250. And then 5 gives us x equals 552. Nah, gosh darn it. All right, I'm just gonna use the calculator, guys. So let's see here. 115. Oh, 50. I'm tripping. All right, 50. All right, so we got 50 for x right here. C is just the value of x. So if C is x and x is 50, then C must also just be 50. And then what is 4 times 50? That is 200. 200 minus 95 is 105. Good. Okay. So use the parallelogram to the right to find the measure of angle A. Okay, so this is very important because now look, we're getting into 6.2 now. We're talking about parallelograms. Parallelograms have 5 special properties, right? Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Adjacent angles are supplementary. And the diagonals bisect each other. Okay, so I'm gonna erase that because it's gonna make our life a little complicated here. So they want us to find the measure of angle A. They want us to find this. Well, if we know it's a parallelogram and opposite sides are congruent, A should just be 61, which it is. Okay, what about this? Use the parallelogram to find the length of AB. Well, we know that opposite sides are congruent in a parallelogram. So if this is 25 over 26, AB also has to be 25 over 26. Okay, use the parallelogram to the right to find the measure of D. Well, D is adjacent to this 73, so we just got to do 180 minus 73. 10, 7. The answer is 107. Okay, so let's do this next one. A lot of people get confused with this one. Remember, guys, opposite angles in a parallelogram are congruent. Adjacent angles are supplementary. So 3a plus 37 plus 6a plus 17 is equal to 180. 3a plus 6a is 9a. 37 plus 17 is 54. 180 minus 54. Did I get that right? Yeah, 9a divided by 9 should give me 1 and then 4. So the answer is 14. Good. All right. So the next one, it's another parallelogram. And what do we know about parallelograms and the length of the sides? That they are congruent. So let's set them equal to each other. So let's set this and this equal to each other. So a minus 7 equals 14. And we also have 2a minus 7 equals a plus 14. So I think it's going to be a little bit easier to find a in this equation than this one because there's 2 here. So I'm just going to do plus 7 plus 7. So a is 21. Well, now that a is 21, I can now plug it in for the rest of them. Well, this one I didn't really need to because if AD is 14, BC also has to be 14. So AD is 14 and BC is 14. Now that I have my A, let's plug it into any one of them. This one's probably a little bit easier just because we're adding instead of multiplying and subtracting. So 21 plus 14 is 35. So if this is 35, BA also has to be 35. 35, 35. All right. Let's do the next one. Find the measures of the numbered angles in parallelograms. So once again, guys, remember that a parallelogram is just the shape of what we know to give us our alternate interior, right? And alternate interior angles in lines that are parallel is what? Congruent. So one has to be 23 degrees. Okay. What else? What else? Okay. We know that, change the color. We know that these two guys are what? Supplementary. So let's find the measure of angle 3. So angle 3, let's just put it as x. So if angle 3 is x plus 23 plus 137 equals 180. Why am I adding the x and the 23? Because this is the angle that is supplementary to this one. The entire angle, not just the 23. So it's the 23 plus this x, or this measure of angle 3, plus this one equals 180. So we have to take into account all of them. So 23 plus 137 is 160. And then 180 minus 160 is 20. So that means if x is 20 and x is also equal to this 3 over here, then that means 2 also has to be 20 as well. So I have 23, 20, and 20. 2 and 3. 23, 20, 20. Perfect. Okay, so let's move on. For the parallelogram, AB is equal to 10. Okay, so this right here is equal to 10. and BD is equal to 15. Okay, find the length of AC. Well, AC is this whole thing. So if we know that in a parallelogram, the diagonals bisect each other, well, if I know that AB is 10, what do you guys think BC will be? It'll also be 10. So if this is 10, if this is 10 and this is 10, what is the entire AC? It should just be 10 plus 10, which is 20. And that's our answer right there. All right, let's move on. Use the parallelogram to find measure of BAD. So BAD is this triangle. Which measure specifically? The one in the middle, guys. Remember, BAD, the one in the middle is the one we care about. So we care about this angle. Okay. Oh, I already know my answer, right? Because this is a what? A parallelogram. And what do we know about this and this? They're alternate interior. So the answer is just 33. All right, cool. Okay, let's go to the next one. Use the parallelogram to find the measure of DBC. DBC, so this one. DBC, it's always the middle one. Now we could just use the triangle angle sum theorem. So this B, let's put measure of angle B. No, let's put X. This is X. So we can do X plus 59 plus 38 equals what? 180. There's 180 degrees in a triangle. So when we do this math, when we subtract this and subtract this from here, we're gonna get 83. Okay, this is a good question right here. What are ED, and FD in the figure to the right? Well, what's the first thing to notice? I have 3 parallel lines, and I also have this transversal. What specifically do I know about this transversal? It was cut up into what? 6 and 6. It was cut up into congruent segments. So remember, if I have at least 3 parallel lines that was cut up, 3 parallel lines that a transversal passed through it, and that transversal cut the parallel lines into congruent segments, then I know that every other transversal that I draw is also going to be cut into congruent segments. So let's look at this 9. If this EF is equal to 9, then what does the DE have to be? Also equal to 9. So now I know ED or DE, it doesn't matter, is 9. And FD, this whole line segment right here, would have to be 9 plus 9, which is 18. Okay, this one looks a little bit more tricky, but let's tackle this like we always do with doing the, let's write down what they give us, and then let's see what we know. Okay, PQ is equal to QR is equal to RS. PQ is equal to QR is equal to RS. Okay, so I know I have 4 parallel lines, and if I have at least 3 parallel lines and a transversal that was cut up into congruent segments, I know that every other transversal, including this TU and this WV, will also be cut up into congruent segments. So that means if this is 2.6, this is 2.6, and this is also 2.6. If this is 3.4, this is also 3.4, this is also 3.4. So let's see what they want us to actually find out. They want to know WV. Where's WV? WV is this whole thing. So we know that if WY is 2.6, YX is also going to be 2.6, and XV is going to be 2.6. So that means this whole WV will just be 2.6 times 3, which is 2.6 times 3, 8167.7.8. Good. Okay, let's look here. Find the values of X and Y in parallelogram. That's very important, parallelogram. Okay, PQRS. So PT, so let's write down what they gave us. PT is equal to Y. Okay, TR is equal to 4x plus 1. QT is equal to 2y. TS is equal to 3x plus 12. Okay, cool. So I know it's a parallelogram, so I automatically know this and this are equal and this are equal. So that's good to know. Now they want me to find x and y, so let's write down what we know. Oh, whoops. Very important, right? I have to separate it because the only shapes that all the diagonals are congruent are in square and rectangles. We're gonna go through that in a couple minutes, but it's always good to refresh. So let's write down this PR first. Let's write down this one first. Y equals 4x plus 1. Now let's write the other diagonal. 2y equals 3x plus 12. So this is a system of equations, and we know that if we already have a variable isolated, let's just use substitution. This y is isolated, so let's just plug in this y right there. So it's going to be 2, 4x plus 1 equals 3x plus 12. Distribute 8x plus 2, 3x plus 12, minus 3x, minus 3x, minus 2, minus 2, 5x equals 10, so x equals 2. All right, perfect. Look, x equals 2. So now let's plug that into any one of these to find out what y is. I'm going to plug this onto here. What is 4 times 2 plus 1? That's 9. So y should be 9. Perfect. Okay, let's take a look at this one. Your classmate says that QV is equal to 10. So he's saying that all of this is equal to 10. Okay. Explain why this statement may not be correct. Okay, so, okay, I get it. So he's saying that this whole thing is equal to 10. So if this whole thing is equal to 10, then, and if QS is 5, then he's saying that SV also has to be 5. So then he's therefore saying that these are congruent segments. But there's something wrong. Yes, this transversal was cut up into congruent segments, but are these lines parallel? Do they have the parallel notation? No, they don't. So we cannot say this to be true. So it is not given that PQ, RS, and TV are parallel. Yeah, exactly. Okay, good. So now we're getting into 6.3 territory. So let's see, for what value of y must LMP be a parallelogram? So it's saying, if you're gonna make the claim that this is a parallelogram, what does y have to be for you to be like, yeah, that's valid. This is indeed a parallelogram. Well, what do we know about parallelograms? The adjacent angles are supplementary. So in order for this to be a parallelogram, these two adjacent angles, or these two adjacent angles, whichever, have to be supplementary. So 180 equals 76 plus y minus 76, 104. So y is 104. Y has to be 104 in order for this to actually be a parallelogram. And if this is 104, we also know that this M has to be 104. That's just extra stuff. Okay, let's look at this. Can the following quadrilateral be proven to be a parallelogram? Yeah, because for something to be a parallelogram, if it's going to be parallel on one side and also on those same sides be congruent on opposite sides, then that is indeed a parallelogram. So let's see. So I can take off this no, I can take off this no. So yes, it is a parallelogram because one pair of opposite sides is congruent and parallel. Okay, that's good. It is a parallelogram because one pair of opposite sides is congruent and the other pair of opposite sides is parallel. That means they're saying this, and then this. This does not tell me anything about if there's a parallelogram or not. It has to be on the same margin. It has to be on the same opposite sides, all right? So please read this question. Do not get confused. Do not just pick the first yes you look at, okay? Read them both. Okay. Can the following quadrilateral be proven to be a parallelogram just based on this information? Well, what did we just learn about parallelograms? Adjacent sides have to be what? Supplementary. So 135 plus 35, I can already tell it's not supplementary. It's going to equal 170, right? 135 plus 35 is 170, and that cannot be a parallelogram then. So no, it cannot be proven because it does not have an angle that is supplementary to both its consecutive angles. Yeah, this one nor this one. So that's how we know that that's just flat out wrong. Okay. So let's move on. For what value of x must ABCD be a parallelogram? Once again, so it's saying, okay, we want to make the claim that this is a parallelogram. Well, in order for us to make that claim, the diagonals have to what? Bisect each other. So this CA is already bisecting BD because of the tick marks. So now we have to see if this BD is in fact bisecting this AC. So what does X have to be in order for this BD to actually be bisecting AC? Let's figure it out. They have to be congruent in order for them to be bisecting each other. So let's put them equal to each other. Minus 7x, negative x equals negative 5. Divide by negative 1 because there's an invisible 1 here. Divide by negative 1. X equals 5. So in order for this to be a parallelogram, x has to equal 5. Let's look at this one. For what values of the variables must A, B, C, D be a parallelogram? Once again, so the opposite angles, so we could either do that these two guys are supplementary, but that's going to be a little more complicated because I have an x and a y. So it's going to be easier is if I say the opposite angles are, well, if I use the fact that the opposite angles are congruent. So if I write that, then I'm going to be able to find x and y pretty easily. So 3x, let's do this one first. Let's do these first. So 3x is equal to 4x minus 21. And then the other one is this one and this one. 3y is equal to y plus 78. So subtract 4x, negative x equals negative 21, so x is 21, minus y, so 2y equals 78. So my y is what, 39, right? 39. So yep, 21, 39. Cool. All right, so let's look at this next one. For what value of x must ABCD be a parallelogram? All right, so look what they're giving me for the x's. They're giving me the alternate interior, right? Because if there's a parallelogram, I can say this, and this is my transversal, which will make these my alternate interior. So what do we know about alternate interior angles inside of parallel lines? When it's transcribing parallel lines, we know that they're congruent. So 10x plus 5 is equal to 14x minus 7. So minus 10x plus 7 plus 7. 4x equals 12. So x is equal to 3. Perfect. Okay. Let's look at this one. For what values of the variables must A, B, C, D be a parallelogram? Well, now we are looking at sides, right? Where are my x's and y's? Where are my variables? On the sides. And we know in a parallelogram, the sides have to be congruent. So let's set the sides congruent to each other. So I have 2x plus 2 equals y plus 4 for these two. And now for these two, I can write 2y minus 13 is equal to y minus 3. That's a 3, right? Yeah, 3. Okay. So let's solve this one. I'm gonna solve this one because it has only y's. This has an x and a y. So why would I make my life complicated? So minus y plus 13 plus 13. Y equals 10. And now if I know that y equals 10, I can find x by just plugging this right into here, substitution. So 2x plus 2 equals, what is 10 plus 4? 14 minus 2. 2x equals 12. So x is equal to 6. So my y is 10 and my x is 6. Perfect. Y 10, x 6. Cool. So now, okay, this is a really good question, right? Because it's doing the distance thing that we've been talking about. But instead of using distance formula, we're going to use the Pythagorean theorem. So let's find PT first. Oh, let's read the question. Find the lengths of the sides. Okay, yeah. So I can go from this to this. I can go up 3, 1 to the right. So now this becomes my C for the C squared equals A squared plus B squared. So C squared, because we don't have C yet. What's A? Let's make A 3. What's 3 times 3? 9. Let's make B 1. What is 1 times 1? 1. So C squared is equal to 10. Square root of 10 cannot be factored anymore. So my answer is just square root 10. So this is square root 10. Let's see if we take another 3 to 1 pathway that we did from TP to go to RA, then we know that this length is also going to be square root 10. So 1 to the right, 1, 2, 3 up, perfect. So 1, 3. So I know this is also square root 10. Okay, now in red, let's do this PA. No, not red. Green. So 1, 2, 2, 1, 2, 3, 4. Okay, what is 2 times 2? 4. What is 4 times 4? 16. C squared. So C squared is equal to 20. Now, square root of 20 can actually be factored out. So we can break it down to square root 4 times square root 5. 4 is a perfect square, so let's take it out. So now we're going to have 2 square root of 5. So my answer should be, oh yeah, this side length right here is 2 square root 5. So let's say if we took the same path up here that we did for down here. 2 down, 1, 2, 3, 4 to the right. So still a 2 and a 4. So that means this is also 2 square root of 5. Look, 2 square root of 5, square root of 5, 10, 10. Make sure you're writing it on the exact line segment, okay? Okay, so we're going to stop here because this is the beginning of 6.4. So I'm just going to make a part 2 video like right now, all right? So I'll see you guys in about like